demand, and a variety of ways in a variety of ways. So some of the sources of data. The old way, which was surveys, that's still it, except there. Then we move to transaction systems, credit card data, telephone data, telecom data. These are all transaction data, bank data. Free text. This is where a lot of work is going on because survey data is solicited information. Transaction data is derived information. Free text is unsolicited information. It is information that we type out. You will see that on Google or any other email, Gmail or any other email provider which you are using, your ads which are reflected is based on the email which you are writing. This is text mining. And therefore, Google is reading the pattern of your mails to provide you advertisements which are relevant to you. You may like it or not like it, that's a different matter. But it's providing ads which are relevant to you and making money. And advertisers are promoting the products from free text which you're writing in your mails. Digital images. This, we do believe, is going to become one of the biggest sources of information on which a tremendous amount of analytics or pattern understanding can be applied. Facial expressions. Today, you have software and analytical methodologies which can decipher whether a person is smiling or not smiling. So theoretically as well as practically, you can measure, if you're running a retail shop, when a customer has entered your shop, whether he was frowning and when he leaves he was smiling. That means your team has serviced the customer well. So you can, your business intelligence software sitting on top of which there's an analytics facial recognition software, and if you integrate these two together, can provide reports such as how many customers were happy rather than filling up a survey. And you all know how the survey information is mostly not valid. So digital imaging is going to be a massive source of information for understanding patterns. Sensors. I was reading an article recently where a company is creating a database of the biggest of all the heartbeats in the world to model whether somebody has a high propensity to have a heart attack or not. It will be an application-based sensor. It will be an app which will be there on your phones, which can predict whether a heart attack can potentially happen. Now this is completely an analytics-driven engine which is correlating the heartbeat to potential mishap. So sensor-based information is going to become even huge. Voice. There's tremendous amount of voice transaction which happen, which is through call center, through the speak which we do, for calling when we are talking on the phone. The tone of the voice can be modeled in terms of, is it a happy tone, is it an aggressive tone, and one can understand derive information whether the person speaking on the phone was aggressive or sad. Information like this can be extremely valuable for call centers and BPOs. They'll know exactly, they can get daily report into the millions of calls they're having in terms of how many calls started off as irate and ended up as soft. One doesn't need to have any customer survey. One doesn't need to have any kind of SMSs coming in, are you happy with the service? It is that simple from the tone. And this can be derived from analyzing tone and correlating that using a set of correlations to personal happiness or irateness. GPS information. Today all of us carry cell phones. That information can be used for better traffic management. It can be used for marketing. It's already being used with the apps which are created, which provide offers based on where we are located. So the point I'm trying to make, friends, is that sources of data are enormous, and as technology folks and business folks, it is up to us to imagine what is the data available and how can we use it strategically. Because we have the tools as well as the tech tools in terms of databases and software functionality, as well as the techniques, which is statistical and mathematical algorithms, to decipher patterns. Now, you may be thinking, okay, Gautam has gone through data, measurement, cause and effect. Now, how do we model? Modeling is, we believe, is the simplest thing possible, provided one understands the concept of that anything can be measured, and one more concept called the n-dimensional plane. Basically, many of you may be familiar with the n-dimensional plane, but I would need to just explain this for another 3 to 4 minutes, because it is a very important part of pattern understanding in where analytics is headed. We have all been familiar with using Excel as well as other software for creating reports which have charts, which are 2 by 2 charts as well as 2 by 3 charts. These charts, unfortunately, are able to provide relationships between only 2 variables, demand and supply, price and quantity. It's only 2 variables, which we all know in today's world is, or even in any world, even historically, is highly inadequate way of looking at data. Therefore, mathematicians historically have brought out a concept called the n-dimensional plane, which is a theoretical concept which basically allows for creating as many axes as there are number of variables, -1. And for a particular event, we plot all the data, for example, data related to that event. For example, if you are trying to measure what will be the demand for automobiles in India in 2012. So we are trying to find a pattern in terms of which will tell us if the demand was, say, 100 last year, how much will it be this year? So what we need to do is, for that 100 demand, we need to create as much as variables which may explain, potentially explain, how the demand got affected. So it can be seasons, it can be GDP, it can be loans, and there can be n different variables. All that information is put in together, and to analyze the relationship between demand and the variables, one needs to build an equation which says demand is a function of these n different variables. Now, this techniques will be used by governmental institutions for the last 50 to 60 years. These are all standard econometric models. However, over the last 5 years, thanks to the huge increase in computing power, explosion of digital data, and most importantly, open source data mining and statistical software, people like you and me can sit in our offices and analyze almost any data that we want to analyze. You have softwares like Hadoop, like SAS, SPSS, which are extremely powerful. And once you start doing that, with the knowledge of this, even at a high level of multivariate techniques, one can model anything. In ATI, which is our subsidiary company of Redwood, we have trained more than 10,000 software professionals in deploying analytical software, analytical solutions. And we know, and that is so simple, because 3 big components are already present, which was not there even 10 years ago.